Hello everybody and welcome back to this tutorial, and right now what we are going to take a look at is something called class inheritance. Now, instead of starting from scratch, you can create a class by deriving it from the pre-existing class. Simply just by listing the parent class in the parentheses after new class name. Now, basically what that means is that we can actually have a class that is going to be the so-called child of the parent class, and the parent class is the class that we created first. And the actual child class will take an actual argument between the brackets, which is going to be the name of the parent class. So basically the child class inherits the attributes of its parent class, and you can use those attributes as if they were defined in the child class itself. A child class can also override data members and methods from the parent. Now that is also something to take a look at. Basically the syntax, the derived classes are declared much like their parent classes. However, the list of the base, or basically a list of base classes to inherit from, is given after the class name. Basically, we know, let me just open up my idle, we know when we define the actual class, we simply just type something like this, class student, and then we actually add the two dots and code the class code. But in order to create the child class, which is going to inherit all of the attributes and actual methods from the parent class, we're going to define it just like this. So class child, this is going to be the name of the class, and in between the brackets you simply specify the parent class itself, and then you add two dots and start coding. Now we don't really need this. We're going to keyboard interrupt, and let us see a simple actual usage of this inheritance, or so-called class inheritance. So right here we're going to take a look at a simple example. So let me just go right here and create a class called parent. We already know this definition of declaring. Basically, if you want to, you can simply just add it as a reminder right here. Define parent class. Okay. Now, we're going to set something called the parent attribute, which is going to be a simple variable, just like our employee count, student count, once we use the points. Basically, this is just a simple variable, which is going to be equal to 100. Now, what we have to do is declare the init function in this class. We're already familiar with the init function. It is going to take the argument self, and basically what our init function will do is it will call a print statement. So print, and that print statement will say calling parent constructor. Simple as that. Now this will get called every time we actually add an element to this class. So let me just go right here, go to the next line. The next function that we are going to define is going to be the parent method function. So def parent method, and as every other function in the class, it needs to take the self argument. And this actual method right here will simply just print calling parent method. Oops. Okay, so calling parent method, and the last function to this actual class parent, or not last, actually one before last, is going to be the set attribute function, which is going to take two arguments. One of them is the self argument as always, and the other one is the actual attribute itself. So right here, if we just define it and go right here and call it from the actual class itself, which we can call it because we defined it right here. Therefore, this actual variable can be called even outside of the class. So parent.parent attr equals attr. And the get attribute, which is our last function to this class, is going to simply print the value of this parent attr, which is defined at the beginning to be equal to 100. So define get attribute, takes the argument of self, it will print parent's attribute, and then it will, we can basically add the parent and then parent attribute, which is going to be our number that is stored in this variable right here. Okay, so this is our normal actual class. We saw the example of creating a class like this before. So nothing really new to us. What is new to us is now that we're going to actually create another class that is going to be the inherited class of this. Basically, it is going to be the child class, and it will actually be able to access all of this stuff from the parent class. Let me just show you. If you just type here class and call it child, and in between the brackets, we know that by the syntax, we need to actually specify the name of the class that we want to inherit, which is the parent class. Right here, you can simply just add as in the upper class, define child class. And we can simply just use the init, which is going to take the self argument, and it will just write right here, print calling child constructor. You can see the difference is that right here in this init function, we actually print calling child constructor, and in the init function in the parent class, we're printing calling parent constructor. And you will see in just a second. Let me just go right down here, define another class, which is going to be the child method. Pardon me, not class, defining another method. So child method takes the argument of self. And right here, what we're going to do is we're simply going to print calling child method. So simple as that. Basically right here, once we actually code this, let's now go through this code. We created the class parent. It has a variable that is set to be equal to 100. We call it parent attribute. Init function, parent method, which is simply just two print statements. The set attribute function from the parent class is just going to set the parent attr to be equal to the attribute itself. And you will see that the last function, which is the get attributes, will simply print the value of this value or this variable right here. Then down here, we created the inherited class, which is going to be our child class, going to take an argument of this parent class that we created up here. And it simply has two functions, which is the init method right here, which is going to simply just print calling child constructor, similar to this, which says print calling parent constructor, and the child method, which is also similar to the parent method, which simply just prints calling child method instead of calling parent method. And right now, if we simply just try something like this, we create an element to the child class. As we can see right here, we can just call it just like this. We don't provide any elements in between these brackets because in our init method right here, we didn't define any specific values for this actual object for this class. So right here, all we have to do is open and close brackets. It will create the instance of a child class. And then if we want to, we can call the function c.child method, which is the actual function right here. And if you, whoops, I just typed here comma instead of actually typing dot. So c.child method, what this will do is it will call its method. So if I just save this, go Python program, child class.py, and I run it, you will see what this will do is it will simply print calling child constructor, calling child method. Now, the reason why it actually printed this out is because the child constructor is printed out as the init function. As soon as you actually define the instance of this class, it will print or it will perform any code that is in the init method right here, which in our case, it is simply just a print statement. Therefore, it printed this out, which is normal. Then once we call the child method from this actual class right here, whoops, not upper class, down class, it will print calling child method. But right now you will notice that if I just type right here something like this, so c.parent method, and I save this program once again, it will be able to also call this print statement from a different class. If I just run it, yeah, it's because we actually need capital P, or let's just lower the P right here. Because right here we also have the lower C, so therefore everything looks better like that. So let us run this, and you can see it will print calling parent method even though we define the instance of this class to be the instance of child class. So once you actually inherit a class with a different class, you can simply just use all of its methods from that specific class, as you will see right here. If I just go something like c.setAttribute to 300, for example, we know that it is 100 for now on. Let me just change this comma to be equal to dot. So c.setAttribute equals to 300. It will call this function right here, which is in the parent class. It will be set to actually, what this actual method will do is it will set the value that is specified in the brackets. It will set to be equal to this parent attribute. Therefore, this parent attribute will no longer be equal to 100. It will be equal to 300. But we also need to call the c.getAttribute in order to actually print the value, so we can make sure that we performed everything correctly. It will print this statement right here, and the parent attribute will be equal to 300. So let us save this, call it right here. Get attribute is not defined. Yeah, it is not defined because I always specify comma instead of a dot. Not really sure why. Let us save it once again. Save it. Run the program, and we can see right here calling child constructor, calling child method, calling parent method, and then parent's attribute equals to 300. So basically that would be about it for the parent and child class. What we saw right here is the example of inheriting every method from a different class into a new class. So you don't actually have to code everything twice. You can simply just define a new class and specify in the brackets the class that you want to take all of the methods from. And as we can see right here, we only added these two methods, and we were able to use all of these 6 methods right here on our instance of the child class. So basically that would be about it for this tutorial. Hope you enjoyed it, and I hope I will see you in the next one. Bye!